Okay, let's use sum or difference formulas for sine to find exact values of these angles that are given to us in radians. So to do so, what we really want to do is we want to stick to some angles that we really know and we're comfortable with. So the ones that we want to play around with are pi over 6, pi over 4, and pi over 3. All right, because we know how to evaluate those in sine pretty easily and cosine. Now, one of the problems on this is that we have pi over 6, pi over 4, and pi over 3. We are dealing with a denominator that's 12 in both of these examples on this video. So what we want to do is really rewrite each one of these. It's always easier to see if you rewrite pi over 6 as 2 pi over 12 instead, right? You'd get there by multiplying numerator and denominator each by 2. Pi over 4 can be thought of as 3 pi over 12. All right, multiply numerator and denominator both by 3. And finally, pi over 3, think of that as 4 pi over 12. All right, so when we play around with these, it's actually easier to see that this first one we can rewrite as sine of 2 pi over 12 added to 3 pi over 12. I'm trying to color code this so you can see where exactly everything gets plugged in. All right, so sine of 5 pi over 12, yeah, that's 2 pi plus 3 pi all over 12. So as we plug into our formula, we're going to use this top version, right, because we have two things added together that made that 5 pi over 12. So I'm going to go over on the right-hand side, and I'm just going to kind of copy down the formula for now. All right, initially what we want to do is have sine of something multiplied by cosine of something plus cosine of our alpha multiplied by sine of our beta. All right, let's try to color code this so you can see exactly where things get filled in. Wherever we see an alpha in our formula, we're going to replace that with a 2 pi over 12. All right, so 2 pi over 12. Or instead of that, actually, let's go back and instead of 2 pi over 12, remember we did say that 2 pi over 12 was the same thing as pi over 6. It'll be easier, I think, for everyone to see exactly as these get filled in if we use pi over 6 instead of 2 pi over 12. But they mean the same thing. All right, and then wherever we see a beta in our formula, we're going to go ahead and replace each of those with 3 pi over 12 or equivalently pi over 4. So pi over 4 gets filled in on each one of those. And now we're off to the races. We can really just evaluate this hopefully fairly easily by using some of these ratios that we know. That sine of pi over 6 is 1/2. Cosine of pi over 4 is square root of 2 over 2. Plus cosine of pi over 6 is square root of 3 over 2. And then finally, sine of pi over 4 is square root of 2 over 2. Now there's some additional reducing down maybe we want to do in this case. We could say multiply numerators, multiply denominators. Same thing with this other fraction. You'll notice we have the same denominator on both of these, so maybe we put them into a single fraction, square root of 2 plus square root of 6, all over that common denominator of 4. So that can be our final answer that we end up with on that one. Okay. Next, let's think about that sine of 13 pi over 12. So this one's going to be a little bit different because 13 pi over 12, we can't just say add any of these two together, it would take more than just that. And what we want to have this written out as to use these formulas is two angles that are added or subtracted that make 13 pi over 12. But we run into that problem that doesn't really work out nicely. So what I'm going to suggest is let's find a reference angle that we can replace 13 pi over 12 with. So first, what I'm going to go ahead and do is think about where is 13 pi over 12? Which quadrant is it in? Well, I know pi, 1 pi is here, and 1.5 pi, 3 pi over 12, or 3 pi over 2. 13 pi over 12 is going to fit somewhere in the middle of these. So somewhere in quadrant 3. So that initial angle wraps all the way around here into quadrant 3. Our reference angle is going to be drawn to the x-axis. So the red angle that I'm drawing in here, that's where our reference angle is going to fit. To find that reference angle, and I'm going to call this reference angle theta bar. To calculate that, what we'll do is go ahead and start with the bigger of the two angles, which is 13 pi over 12, the blue one over up here, 13 pi over 12. And we're going to subtract away the smaller of these two, the pi. Now maybe we strategically rewrite that pi so that we can make our lives a little bit easier. Instead of pi, let's get a common denominator from the beginning and say that's 12 pi over 12. So our reference angle is going to go ahead and be pi over 12. All right, so we would like to fill in our reference angle and make this look like sine of pi over 12. But whenever we use a reference angle, we want to double check one additional thing. We want to check the original angle was in the third quadrant. Well, I use the phrase all students take calculus to remind me which quadrant each one of these functions, these trigonometric functions, is going to be positive in. So all of them are positive in the first quadrant. Sine is positive in the second quadrant. We're dealing with the third quadrant where tangent is positive, but what that means for us is our sine is going to be negative. So as soon as we plug in that reference angle, make sure you get the correct positive or negative out in front. So that's what that negative is in yellow out in front. Next, let's go ahead and try to rewrite this. I'm going to bring along a negative, and this will be sine of, remember, we're trying to go back to one of these nice angles, right, that we've rewritten. So we have a denominator of 12. So we could do either 3 pi over 12 minus 2 pi over 12 to make 1 pi over 12, or 4 pi over 12 minus 3 pi over 12. Either way, we'll get to the exact same solution, so it doesn't really matter. I'm going to go with 3 pi over 12. And again, I'm color coding these. I'm going to go 3 pi over 12 minus 2 pi over 12. Or equivalently, this is going to be negative of sine. And instead of 3 pi over 12, we can think of that as meaning pi over 4 minus 2 pi over 12, which is pi over 6. This time we're going to use the bottom formula, right, because we have a subtraction going on, a difference. And wherever we see an alpha, we're going to replace it with a pi over 4. So let me write out our formula and we'll start plugging in. All right, so this is going to be equal to the negative of, big set of parentheses, sine of something, our alpha, times cosine of whatever our beta is, minus cosine of alpha, sine of beta, I'm running out of space. And then I'll close off my parentheses. It's run out of space down here. So hopefully that makes sense that pi over 4, going to go here, going to go here, and then pi over 6 goes right here. And it goes at the end here also. This is going to get a pi over 6 for preparation. All right, from here, it's mostly a matter of going ahead and filling in. Take away my work for reference angles here. The filling in shouldn't be too bad. We'll have the negative out in front. Big set of parentheses. Sine of pi over 4 is going to be square root of 2 over 2, multiplied by cosine of pi over 6, square root of 3 over 2, minus cosine of pi over 4, square root of 2 over 2, and then sine of pi over 6, I know it's written poorly over there on the right-hand side, is 1/2. All right, let's go ahead and distribute that negative, bring it to the inside. So it's going to be negative of, combine this fraction together, square root of 6 over 4. Remember that negative gets distributed to both these terms, so that's going to make that second fraction positive as we rewrite it here. Square root of 2 over 4. And maybe we'll go ahead and combine our numerators together. So negative square root of 6 plus square root of 2 all over 4. All right. So hope this helps out as you're working on rewriting these using the sum or difference formulas and getting to nice exact values in the very end. All right. Appreciate you paying attention, following along to the end. Those are some good solutions. Hopefully not too much work filling in, seeing exactly where things got filled into the formulas for alpha and for beta. All right, good luck as you're working on these. Rewrite the original angles you want to work with, though. Make sure you have that same denominator. It's way easier to visualize exactly what's going to add or subtract to make the appropriate angle.